Okay, so let's start with the transform component. Okay, I'll just make a square here in the scene. So you see here, this is the transform component, and basically the transform has the position in world space on all three axes. So in 3D, it has the rotation of the object on all three axes, and then the scale, which is the size of an object. Now you can modify these values here in the inspector. You see, just push the mouse on top of whatever variable you want to increase. So let's say we want to increase the scale on the x-axis. You can just click here and draw in either direction. So you either decrease it or increase it in size. So you can do that for each value here. Now for the rotation in 2D, we only care about the z-axis. So you can rotate it clockwise or counterclockwise here with the Z. The other was, if you do that, if you try to rotate on the x-axis or the y-axis, you rotate it in 3D, you see. So you don't do that usually in 2D games. Now let's say we want to move this around. We just use here in the scene this. You see, you have some tools here at the top left corner, so you can move the scene. You can select something and move it on one axis like that. So you can move it on a specific axis, or you can move it in both axes at the same time. You just click this blue square. Now you can move it with the mouse. Then you have the rotation tool, so you can rotate in here as well, and you can resize it as well. Now objects can have children. Okay, so let's create another square here. You see now this square here, I'll make it another color so we can differentiate between these two. Let's make it green. So now this is a child of the other square here, the white square. And that means a couple of things. One is, if I modify any property of the parent, it will affect the children. Okay, so let's say I rotate it. You see the child rotate with it as well, and same goes for position. If I move it, it goes with the white square, and even with the scale. If I increase the scale, the children um, are changed in the same way. Um, Now you can have children of children as well. So you can let me do this now. You see the child has a child as well now, and this one. So the child was a child. Now if I move the parent of all of these, this will affect the children of children as well. Okay, but you see, if I modify just the parent, so that this, not the main one, the parent of the last child, then uh, this will only affect that child, not the parent will not be affected. Uh, Now let's make an empty script, and I'll explain some code. Meanwhile, while this loads here, let's go to the documentation here. So this is the documentation for the transform component, and we have some properties that I don't know all of them, but I will explain the most important ones. But first, we have to wait 1 second for the script to load. Now, another important thing is the transform component is for objects in the world space. UI doesn't use transform; it uses another component. So we'll discuss that. We'll discuss that later. So now I'll just show you a couple of things related to transform. For some reason, this doesn't load. 1 second, sorry, I'm having technical difficulties. I don't know what's happening. 1 second, sorry guys. Don't know why this is not open. Okay, now it seems to be working. Okay, sorry about that. For some reason, it takes a lot of time to load. Not sure why. Okay, so we'll ignore the update function. We don't need that. 1 second. I'm lagging really hard. I'm not sure why. Yeah, I have no idea why I'm lagging. Okay. So let's start with the transform variable. So if you want to save a transform, you just name it transform and give it a name. So now that's a transform variable. Now let's say we want to get just the position from the transform. Okay. To get that, just say create a vector tree because we have 3 dimensions, and then give it some name. So let's say some position, and then you just select the transform that you want, and then say position, and that with this you save your position. For the rotation, it's a little bit different. Let's say rotation from Euler angles. Is that it? Yes. So with this you save the rotation, okay, in angles, so 360 degrees. And for the scale, you say transform local scale. And that, for some reason, they decided to just have so for position, this is the position in world space, okay, but you can also say the position relative to the parent, and that would be position, let's say that would be local scale, like that, and that's the position relative to the parent. And excuse me 1 minute, be right back. Sorry about that. I'm back. So that's the position relative to the parent, and the same goes for rotation. You can say let's say another vector 3. Wait, yes, transform local Euler angle. So that is the rotation relative to parent, okay. But this here, the scale, this works for both uh, for both the scale in the world and relative to the parent. So let's say this transform here does not have a parent, then that will be the scale in world space. But if this transform has a parent, then it will be relative to the parent. So this works both for objects in the world space and children. So that's how you save stuff from the transform component. Now, let's say we have children, and we want to know how many we have on an object. For that, so count children of transform. Then we just create an integer, call it number children, and that will be transform child count. With this, you get the number of children. But let's say we want to select a specific child of this subject. For that, select the first. Let's say we want the first child. We say transform child. Let's call it child transform, and then you just say the transform of the parent, and then you say get child 0. So that would be the first child, but you can put whatever number in here. But just make sure that you count correctly, because we start counting from 0, not from 1. So that's how you select the child. Let's see what else. Let's look at the documentation 1 second. Yes, another important thing is if I say vector 3 up like that, that's just up in the direction up, but relative to the world space. But what if we want the left, right, up and down of the of this object? So in other words, let's let me just delete some stuff from here. Skip the white square. So we have this square here, and we will rotate it like that. And now we want the forward of that. Sorry, the up relative to the object, not in world space. If you want to do that, instead we say That's what we say. Transform up, so that will be up relative to the object, so not in world space. Okay, and you can say transform up, you can say down, but let me make a variable here. Okay, so that's the up relative to the parent, but you also have down, you have left. We got. Oh, never mind. I guess you have just up and forward. So that's another thing. Let's see. Now, what if you want to select the parent of an object? How do we do that? So to select the parent, we just say transform parent transform. Let's see. So we say transform dot parent. That's the parent transform component. I guess that's everything. Now, how do we rotate and move by script? And also we look at this here, look at function. Now let's say we have an object and we want to deparent it, so it's no longer a child of the parent. So on parent object, for that we just say transform parent equal null. So now this will not have, this object will not be child of anything, will be just in world space if I say it like this. Okay, let's see. Translate, rotate, yes. How to move an object using teleportation. So we're not using the physics system, we just teleport it towards a direction. So for that, you usually do it in the update function. Okay, but so you do it in the update because you want to move it every frame sometimes, but uh, uh, that's not important. I'll delete update. So to teleport it, object direction, you just say transform, the transform of the object you want to move, and then you say translate, that means move, and then you have to have a certain direction. So let's say we want to move it towards the right in world space. Okay, that's the right in world space, and then you multiply by some value. So let's say float move speed. So you multiply that by some value, and if you do it in the update, you might want to multiply that by time delta time. So it's not frame dependent, the move speed. It will be the same regardless of the frame rate. So that's how you move it. Now how to rotate it. Just say transform rotate and specify an axis. In this case, being a 2D game, you do it on the z-axis, so you would say vector 3 forward. But you can also say backwards, back like that. So if you want to rotate it clockwise, you say forward. If you want to rotate it anti-clockwise, you say back. So you have to specify an axis, and then by some amount you rotate it by some amount on that axis. Okay, so that's how you rotate. This here, look at that's to rotate it an object so that it looks at another object, but in 2D we don't use it. This is only for 3D. Okay, so this will rotate an object to look towards another object. Now let's say we have the transform of an object, but we want the whole game object. So for that, that's very simple. The whole game object. So for that, you just say transform game object. Okay. So let's create a game object variable from object. So you just say transform game object, and with that you can select the whole game object. To get how to get components from an object. So let's say in this case we just have a square, and let's say we want the sprite render from that. So we say sprite render, and then we use the. And now here you can use two things. You can use the whole game object or just the transform. So it works both with the game object and the transform. So let's say transform, and then get component, and then you specify. In this case, it's the sprite renderer, but this works for any component. Okay. So you can either say transform get component, or you can say the whole object like that, and both work. How to check if this object has a certain tag. So a tag basically is a category. By default, it's untagged. Every object when you create it by default is untagged. But here you can click on this and create your own categories. So these are just categories. So let's say square. Let's call it square. Okay. And now it has a category. And to check if our object has that certain category, check if an object has a certain tag. So we say if the transform of the object, but here you can also use the whole game object. So you either say the transform or the whole game object, and then you say compare tag, and here you specify in text which tag. So in this case, let's say square, and with that you can verify if an object has a certain category, so tag. Let's see what else. I guess that's it for the transform. Okay.